Section 3.4, Library of Functions, Piecewise Defined Functions. All right, so there are two different topics we're going to look at in this section. We will first cover the library of functions, and then later we will talk about piecewise defined functions. We will start with the library of functions. And basically what this is going to be, these are going to be 6 different functions that you have to be able to graph by hand. Okay, you're going to see these a lot in the next section. In section 3.5, we will study transformations of graphs, and you're going to be transforming these 6 functions. Okay, so you have to be able to know specific points that they go through. Okay, knowing these functions will make your life easier in the next section. Okay, so let's take a look. We will go function by function. Each one has a name, which you do not really need to know, but we will talk about the formula, and then we will make a table of values to graph each function, and then we will use that table of values to actually graph the function. Okay? All right, so here we go. Library of functions. You must be able to graph by hand the following functions, identifying at least 3 specific points on each graph. All right, the first function here is going to be the identity function. It has the formula f of x is equal to x. Okay, so like I said, we are going to make a table of values to understand what this graph looks like. So remember how a table of values works. Okay, so basically we are always in charge of the x value, and then we're going to pick those, and then for each x value we're going to plug it into the function and get an output y, and then that will give us a point xy to plot. Okay, so again, look at this formula. It's f of x is equal to x. Remember, f of x is the same thing as y. Okay, so basically you can think of this function f of x is equal to x as the same thing as y equals x. Okay, so that's how it's going to work here. Okay, so I tell you what, let me do it this way. I'm going to write it right here. Okay, if you look at f of x is equal to x, that's the same thing as y equals x. Okay, so you are always in charge of x. We get to pick x. Okay, so it's especially important, especially if you don't really know what the graph looks like. You want to pick a variety of x values. Okay, so I'm going to pick 0, and then I'm going to pick a couple of positive things, and then I'll pick a couple of negative things. Okay, you want a really good idea of what the graph looks like, so you can accomplish that by picking a variety of x values. Okay, so I picked some things kind of randomly. I kind of centered myself around x equals 0, and then I picked some negative things and some positive things. Okay, so we're going to take each x value and plug it into the formula, which is again y equals x. That's going to give us our y value, and then we'll have a specific xy point to plot in each case. Okay, I'm going to start in the middle with x equals 0. So if we plug x equals 0 into our formula, we're going to get y equals x. So we're going to get y equals 0. Okay, so the point that we're going to plot is going to be if x equals 0, y equals 0. Okay, so that's the origin. Okay, and then again, if we move on to the next x value, I'll go to the positive x values. If x is 1, plug it into the formula. That's going to tell us that y is equal to x, so x is 1. Okay, so this point will be if x is 1, y is 1. And then if we plug in x equals 2, we'll get that the y value is equal to the x value, so y will equal 2 here. Okay, so again, for this specific point, if x is 2, y is 2. Okay, so you can kind of start seeing why this particular function is called the identity function. So basically, whatever your x value is, the y value is going to be the exact same thing. Okay, so I'll do one more positive value here. If x is 3, then y is also going to be 3. So the graph will go through 3, 3. And then I'll go do a couple of negative values. So if x is negative 1, we'll plug it in. That means our y value is going to be the y value is going to be the same as the x value. So y will also be negative 1 here. the graph will go through the point if x is -1, y is also going to be -1. And then I'll do one more. If x is -2, we plug that into our formula. We're going to get that the y value is the same as the x value, so it's going to be -2. Another point on this graph is going to be -2, -2. Okay, so we've got a lot of points here that we can plot. Okay, so I'll start at the top here. So here's -2, -2, -1, -1, 0, 0, 1, 1, 2, 2, 3, 3, and you can plot more if you wanted to, but you can definitely see what this graph is going to look like. It is a line. Okay, so I'll go ahead and connect the dots here. Okay, so it'll look something like this. Okay, and the graph is going to keep going in both directions forever because you can plug in whatever you want for x. Okay, so to show this, I'm going to put arrowheads on the end here to say that the graph continues in this direction forever. It's going up this direction forever, and it's going down in this direction forever. So this is what the particular graph looks like. Okay, you may have also looked at it this way. If you're dealing with y equals x, okay, think of y equals mx plus b here. Okay, it fits that bill. Okay, for y equals x, the m value is 1 and the b value is 0. Okay, because you can do y equals 1 times x plus 0. That gives you the same thing as y equals x. Okay, so this is a line with slope 1 and y-intercept 0. Okay, and that is reflected in the picture here. All right, so this is what the identity function looks like. We need to state its domain and range. Okay, so domain you can either get from the picture, or you can just think about how we chose our x values. Remember, domain is all the x values that your graph covers. Okay, when we chose x values, we could basically plug in whatever we wanted. We could plug in x equals 0, x equals something positive, x equals something negative. We never got into trouble. So the domain is going to be all real numbers. Okay, and if you look at the picture, the leftmost point on the graph, well, remember, the graph keeps going this way forever. So this left side of the graph is, spanning the entire negative x-axis. And then in this direction, the graph goes up forever. So this right part here is going to cover the entire positive x-axis. Okay, so the domain here is going to be all real numbers. And actually, the range is going to be as well. Okay, all real numbers. Range is all the y values that your graph covers. So remember how we did that? We look for the lowest point on the graph. Okay, the line keeps going down, 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 down forever. So the lowest y value you can think of as -infinity. And then on this side, in this direction, the graph keeps going up, 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 up forever. So you can think of the highest y value as +infinity. Okay, all right, so that was the identity function. Let's take a look at the next one. Okay, so now we're going to move on and talk about the square function. Okay, the square function is f of x is equal to x squared. Okay, we're going to do the same kind of thing. We're in charge of x. Okay, I'm going to pick, the same x values pretty much that I picked before. Okay, again, if you really don't know what a graph looks like, it's a great idea to pick 0, something positive, something negative. The more you pick, the better your picture will turn out. Okay, so we're in charge of x. We've picked our x values, and we're going to plug each x value into the function to get the corresponding y value. Okay, again, our function is f of x. That's the same thing as y equals x squared. Okay, so basically we're going to have to take each x value and square it. Remember, x squared means x times x. Okay, so I will start with -3 here. Okay, if x is -3, that means the y value is going to be -3 squared. That's the same thing as -3 times -3. Negative times negative is going to give you positive. So this is going to be +9. Okay, so if x is -3, the y value is going to be +9. And that will be the point that you plot on your picture. Okay, continuing on, if x is -2, that means the y value is going to be -2, that quantity squared, So if you square -2, that means you multiply it by itself. So -2 times -2 is +4. So the graph will also go through the point -2, +4. If your x value is -2, the corresponding y value is +4. Okay, moving on to x equals -1. Okay, if x is -1, the corresponding y value will be -1 squared. Okay, that means we're going to take -1 and multiply it by itself. -1 times -1 is +1. Okay, so at this point, the x value will be -1, the y value will be +1. Okay, moving on to an x value of 0. Okay, so if x is 0, we're going to plug that into the function. So we're going to get y is equal to 0 squared. So 0 squared means 0 times itself. 0 times 0 is 0. So if x is 0, y is also 0. So this graph is going to go through the origin. Okay. Next, x is equal to 1. Okay, so we're going to take x equals 1, plug it in. So the y value will be 1 squared, which is 1 times 1, which is 1. So if x is 1, y is also 1. If x is 2, plug it in. We're going to get y is equal to 2 squared. That is 2 times 2, which is 4. Okay, so an x value of 2 leads to a y value of 4. And then lastly, if x is equal to 3, the y value will be 3 squared, which is 3 times 3, which is 9. So if x is 3, the y value is going to be 9. Okay, so we have a lot of points to plot to make this function. Okay, so here we go. I'm going to start plotting them. Okay, so I'm going to start with -3, +9. That's going to be right here. Okay, and then the next point is going to be -2, +4, -1, +1, the origin, and then the point 1, 1, 2, 4, and then 3, 9. Okay, and if you notice, we get this U-shaped graph. It is indeed a parabola. If you look at your function, you have something squared. And we know if we have something squared, that's a quadratic function, the graph is going to be a parabola. Okay, so I'm just going to connect the dots with a U-shaped graph. Let me try that again. Here we go. Let's do this. Sometimes these are hard to draw. All right, so it's going to look like this. All right, on the endpoints, I'm going to put arrowheads, okay, because the parabola is basically going up forever on the left side and on the right side. Okay, so this is the graph of f of x is equal to x squared. Okay, all right, let's talk domain. Okay, again, we've done a lot with domain in this class, so we have lots of options when we're writing down the domain. You can, think about the table of values. You can think about the function itself. You can look at the picture. We didn't have any issues when we chose x values. Okay, again, domain is all the x values that the graph covers, or you can think of it as all the x values you're allowed to plug into your function. So when we made our table of values, we could plug in 0, we could plug in positive numbers, we could plug in negative numbers. We never got into trouble, okay? If you look at the function itself, y equals x squared, okay? Or f of x is equal to x squared. That's a polynomial, okay? You have a power of x, okay? The power is not negative. You don't have any fractions. You don't have any square roots. Nothing's going to get you in trouble, okay? If you look at the picture here, the graph goes up, 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 up in this direction and up, 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 up in this direction. So basically, if you're way out here, like at x equals -10, you're going to have a corresponding y value way up here somewhere. If you're at -1,000, if that's your x value, the y value is going to be way up here, okay? So basically, the graph is covering the negative x-axis. Okay, same thing if you look at the positive x-axis. If you're at x equals 10, it will have a y value just way up here off the picture. If you're at x equals 1,000, you're going to have a y value. It's just way, way, way far up. Okay, so the graph is covering the positive x-axis. Okay, Probably the easiest way to see it is from the formula. Okay, we are dealing with x squared. That is a polynomial. Okay, so the domain of a polynomial is all real numbers. Okay, so domain is going to be all real numbers here. Okay, range, we need to look at y values and we need to travel from the low point to the high point. You can actually identify the lowest point on this graph. The lowest point on this graph is going to be the origin. Okay, so the point 0, 0, the y value there is 0. Okay, and remember, every point on this graph is a closed circle. Okay, so we are going to include y equals 0. Okay, y equals 0 is an output if the x value is 0. Okay, so y equals 0 is a valid input, or sorry, it is a valid output. So we do want to include it in the range. And then we look for our highest y value. Okay, so remember, the highest point on this graph, the graph keeps going up forever. So the highest y value is going to be positive infinity. Okay, so that is your range.